Hello, I'm Arun. I'm here with my teammates Uday and Bhim. We will be explaining traffic data classification using KNN algorithm in SDN. So the motivation behind the topic was the need of data classification in 5G and beyond communication network to provide user better services. So the first question arises in our mind, what is the software defined network? So software defined network is basically, we separate out things. The control function and data forwarding function. The control function contains the SDN controller, and the data function contain basically the routers. So the control function takes all the decision. It is basically an instructor which instruct the routers, or you can say the switches, to forward the packets. The just like see you can see the slide, the traditional network devices. So what happened earlier, vendor decide the software as well as the hardware part. There was no standardization, but after the software defined network, what we have here is we can separate out things. We can separate out control plane from its data plane. The hardware part still is the vendor choice, but the control plane is in the user hand. We can basically use AI, ML framework, intelligence, to design our software to provide better flexibility for the user. So the next, so we can see here we have a SDN controller, we have a switch and two routers. So if you see, if I want to forward a packet from H1 to H3, it first goes to the switch. At initial, switch doesn't have any information about the packet, so it goes to the controller. After controller, uh, uh, it goes to the controller, and then controller send the packet information, basically the set of rule, to the switch. And then after the set of rule the switch has gotten, it forward the packet to H3 and send an acknowledgement to the controller that I have send the packet. So now the bean sir will take care.
Hello, greetings. I am Bhims, the second member of this team. So, as we know that with the advent of newer and newer technology in telecom field, we need much more efficient as well as the intelligent methods to handle the data traffics generated in large number of devices in these days networks. So, machine learning is the tool which can cater to this requirement of increasing data as well as data rates and its handling. So we have used machine learning tool KNN algorithm, K nearest neighbor algorithm, to classify the traffic generated in SDN. So in machine learning, as we know that there are two methods. One is the eager learning or the active learning, and another is the instance based learning or the lazy learning. So the K nearest neighbor method we have used comes under the instance based learning, and in terms of supervised and unsupervised learning, if we talk, it comes under the supervised learning. The simplest example of this algorithm is one nearest neighbor, in which the only one nearest neighbor in distance terms is seen and the label is assigned to the incoming data. So next is the three nearest neighbor, in which distance wise three nearest neighbor are seen of any training incoming data, and the label is accordingly assigned. So if we have the n dimensional data in which we have n features of any data point, so all the n neighbors nearest to it, distance is seen, and accordingly the label is assigned. So now our teammate Uday will take over.
So here we have created a simple program which will cater to our need. Here we have just imported some files and libraries, and we have created a data set by concatenating four different data sets. Now, to be honest, we tried to create our own data set, but it was taking too much time. It was too much complex. So after some research, we found some ready-made data set, and we decided to use it. Here we have used the data set as a data frame, and we can see we have 17 different feature, out of which one feature is traffic type or the label. Now, out of those, we decided to drop these four because they were contributing to the computational complexity, and after that still we have 12 features and one output label. Using this, we printed and we got the accuracy for the testing dataset as 99.95%, which is 10% of the original dataset, and we validated that with the validation dataset where we got the accuracy of 99.78%. But the next question was, what is the optimal value of k? And we decided to plot a graph of k versus accuracy, and we found that the first knee point, or k is equal to 101 approximately, would give us the better accuracy and the result in which we can get the value of k and predict the data point. Thank you.